Welcome, focus learners, to this explainer. Today, we're unpacking a massive, complex collision of forces that's literally reshaping the future of electric vehicle infrastructure. We are standing at this really fascinating intersection right now. On one hand, we've got this rapid-fire technological advancement in how we actually charge these cars. On the other, we're seeing sudden massive shifts in federal manufacturing policies. And the thing tying the whole shebang together? The undeniable physical reality of our local power grids. So we're going to break down exactly how these forces are interacting and what it really means for the future of transportation.
All right, let's just dive right in by asking the big central question. What actually happens when millions of new EVs suddenly demand ultra-fast power all at the exact same time? It's like asking what happens when an unstoppable force, this huge, surging adoption of electric vehicles, meets a highly regulated, physically constrained object, which is our electrical grid. We're not just talking about plugging a car into a wall socket anymore. We are talking about redesigning energy distribution on a national scale. To wrap our heads around this whole ecosystem, here's our roadmap for the explainer. We'll start with the 2026 charging landscape and next-gen tech trends. Then we'll hit the Buy America mandate, look at managing the local grid, and finally, unlocking vehicle-to-grid tech.
Okay, part 1, the industry push, the 2026 charging landscape. Drawing straight from the newly released Dreeves 2026 EV charging predictions report, these trends show an industry that is just sprinting toward the future. First up, the industry's leaning heavily into artificial intelligence to manage energy loads. This AI acts like a smart traffic cop, mitigating demand charges and reducing grid strain by intelligently doling out the available capacity. Second, we're seeing the mainstreaming of ultra-fast 350 kilowatt charging. To put that crazy number into perspective, these chargers can bring compatible vehicles to an 80% charge in just 15 to 20 minutes. It's basically the time it takes to grab a coffee. We're also seeing the rise of charging as a service models, which lets businesses host chargers without ponying up massive upfront capital. Plus, these multi-fuel hubs offering both EV charging and hydrogen for heavy-duty commercial fleets. The tech is absolutely ready to scale.
Which brings us to part 2, the federal pivot, the Buy America mandate.
Now, this technological sprint doesn't happen in a vacuum, right? Policy and regulation are just as critical as the tech itself when rolling out a nationwide network. According to a February 2026 press release from the U.S. Department of Transportation, the Trump administration has issued a huge regulatory shift for federally funded EV charger projects. They're proposing a major update to the Buy America waiver. Check this out. The required domestic content for EV chargers purchased or installed with federal funds is being cranked up from the previous requirement of 55%, all the way to a new requirement of 100%. Transportation Secretary Sean P. Duffy clearly outlines the administration's policy goals here. He states, doing so will unleash American manufacturing, protect our national security, and prevent taxpayer dollars from subsidizing our foreign adversaries. So he's establishing that this shift is aimed entirely at prioritizing domestic manufacturing and tackling national security concerns over foreign supply chains. The DOT notes this change is designed to protect Americans from foreign-made EV charger components that might contain cybersecurity vulnerabilities. And they firmly believe domestic manufacturers have the capacity right now to meet these 100% domestic production requirements.
So here's the crucial point. How quickly does this actually happen? Well, once finalized, this mandate is immediately applicable to federally funded EV charger projects that are currently in the acquisition or installation phase, literally right now. What this 100% Buy America mandate means for you as a consumer is that the physical hardware, that ultra-fast charger you plug into on your next road trip, will have a completely different, purely domestic supply chain story. We're talking everything from the steel casing right down to the internal software components. It is a massive, massive pivot in infrastructure procurement. All right, moving on to part 3, the physics of the grid, managing demand. Okay, so if we successfully build all these American-made ultra-fast chargers, what happens down at the wires when everyone actually plugs in? We've talked tech, we've talked policy, but we absolutely cannot ignore the raw physics of electricity distribution. What's really fascinating about the data from the California Public Utilities Commission is how it visualizes the sheer traffic jam of electricity on the grid. Think about it. If we just use passive management, meaning millions of EVs instantly start pulling power the second cheaper time of use rates kick in, it creates this massive rebound peak. It's a synchronized overload on local neighborhood distribution transformers. So yeah, it shifts the problem from the early evening to the middle of the night, but actually, it doesn't solve the local capacity issue at all. Which leads perfectly into part 4, unlocking vehicle to grid, or V2G. To avoid physically melting down those local transformers and, to avoid digging up miles of streets to install massively expensive new wires, both the CPUC and the drives report point to a brilliant, software-driven solution. Now let's clarify some alphabet soup that gets thrown around a lot. The key concept here is V2G, or vehicle to grid. This is a bidirectional capability. It means EV batteries don't just draw power to charge, they can actually send stored energy back to the grid during peak demand. This is different from V2H, vehicle to home, where your car keeps your fridge running during a blackout, or V2X, vehicle to everything, which is just a broader catch-all term. V2G is specifically about turning a whole fleet of plugged-in cars into one massive, distributed virtual power plant. And here is where we see the tangible value for you as a consumer. Because, let's be real, why would you let the power company drain a little bit of your car battery? Well, because they're going to pay you for it. According to PG&E's hourly flex pricing data presented to the CPUC, unlocking this bidirectional charging can represent up to $490 per EV in grid value and bill savings. That's huge. By shifting the load away from peak hours and exporting power when the grid is really stressed out, EVs completely transition from being this heavy burden on our infrastructure to becoming one of its absolute most value-be balancing assets. But let's look at how this builds into reality, because pulling this off is incredibly complex. The CPUC makes it crystal clear that relying on this tech to avoid those expensive physical grid upgrades requires 4 strict steps to go off without a hitch. First, obviously, the EVs actually have to be parked and plugged in when the grid needs them. Second, there has to be enough customer enrollment in these programs ahead of time. Third, if the load response has to be totally predictable. And fourth, and this is a big one, seamless, reliable communication pathways between the grid, the aggregator, and the vehicle are absolutely critical. I mean, if the signal to draw or push power drops out, the local transformer could literally blow. So we'll wrap up this explainer by leaving you with one pivotal question to chew on. We've seen that the technology for 15-minute ultra-fast charging already exists. We know that smart grid integrations could turn our cars into virtual power plants. And we know that sweeping new federal policies demand this infrastructure be 100% American-made. But how effectively will these 3 distinct forces, industry innovation, national security policy, and the raw physics of the grid, actually adapt to one another? That's what will dictate the true speed of our energy transition. Are they going to align seamlessly, or will they clash and create a bottleneck that grinds the EV revolution to a halt? Think on that the next time you see a new charger popping up in your neighborhood. Thank you so much for joining me, Focus Learners, and as always, keep questioning the systems that power our world.